All right, so let's begin a new topic today. So last classes, we're just talking about the radicals. We're talking about a lot of radicals, just how to find the solution of radicals, right? Radicals. So we use the radicals. We will use this radical. This is very useful power and tool to get a lot of solutions. Something right now we say, oh, someone was joining here. So this is a lot of power tools. Just like say, x squared is equal 16. You can use radicals. You get answers directly, right? Say x can equal positive and negative 4. Earlier we talked about this one. We say this one can be changed into here, right? So you can say x plus 4. When you factor, you can factor it. And then got 0. So you got a solution is x can be negative 4 or positive 4, right? This is one method. You use the special product to factor them. You can use the factor process to get the answers. And recently we can use the radical methods to get the answers as well, right? We can use the radical methods to get the answers. We can use the factor progress to get the answers. This is factors. So anyway, right now, so since this is powerful tool, if you say something square equal a real number, you can just directly get the solutions. That would be more easy, right? So this one, something like factor, you need to make sure this number can be factored well, and you got this solution, right? So just say it again, say x squared minus 16 equals 0. So you need to be factor this one. So factor this one, factor into x plus 4. I know I just repeat it one more time because Michelle, several people just joined a little bit late. So so factor, so you can got one of the answer is negative 4 and the other answer is positive 4, right? So if you use the radical methods, that's way much easier, right? If you got 16, so it means x equal positive and negative 4. It's directly, only one step. So this is second radical looks like more powerful than factors, right? More powerful than factors. Let's see some more examples. Say x squared, right now you say 16, what about x of 15? So if I give you this one, if you use the factor methods, so equals 0. So this one looks like you don't like to factor this. It's not easy to be factored, right? Because of 15, if earlier what we measured say, this one can be factored into negative 1, positive 15, or maybe it's negative 3, 5. This is positive 1, negative 15, or negative 5, positive 3. Each of the group, the answer cannot be 0. So it cannot be factored, right? Factor not make sense. But if you use our radical methods, called square root, you can square root it. So square rooted, you can get x can positive negative 15 quickly, right? So factor can be used for some cases. Radical can look like for every cases. Most of more even powerful tool methods, right? So let me see. So x squared equal 81. So you can say x equal positive negative 9. So if x squared equal 80, so you can go what? X equal positive negative 80 square root equal what? 16 times 5, right? 6 times 5 can be positive negative 4 square root 5, right? So this one is definitely not easy to be factored to get these results. But so it means anything. So it means what? So it means anything. If you give you any number, suppose it is a should be a positive number here. Yeah, hello boy. So this one will be C. So X can be this one, positive negative square root 8, all right? So any number, give you any number, and this number just need to be positive or greater than 0, no less than 0, will be get these answers quickly. That's the very powerful tool, right? We use the square radical methods. Right now we can use these methods for some of the higher degrees. Something like say x plus minus 1 square equal a. What could it be? So what could it be? So we can say x minus 1, this can be square root a. So x can be 1 plus minus a, right? So this is the answer. So when we do the factor, it's not easy to do the factor like this. All right, let's give some examples. Examples here as well. We say x squared plus 6x plus 9. We became a little bit higher level, all right? So anyone can anyone factor this one? Did you guys can factor? Make some noise, please. I like to hear everyone talk a little bit.
X plus 3 and x plus 3. Wait, no.
Yep.
Yes.
So this one can be x plus 3 squared, right? So equal 0, right? Right. So you can got x plus 3 should be 0, right? So x can be only one answer. Yeah. Negative 3, right? Did you guys, everyone can do this one, right? Okay. So let me give it that one. X plus 6x plus 8 equals 0. Can you guys do this one? So this one, what's the difference here? Here 9 became 8. So still can be factor, right? You guys can factor this one. 2
X plus
and
4x
4.
plus 2.
You can factor, right? So it can be negative 2 or negative 4, right? I have two answers. Everyone can do this, no problem. Everyone can do this one, no problem, right? So if someone say, okay, this one became, you right now is 8, 9, 8. What about 7? Can you guys do this one?
X plus 1, x plus 6.
No.
What?
Nope, you cannot do that, right? Unless is this one, cannot be factor. Can you guys factor this one?
X minus, no.
X plus 7, x minus 1.
Nope.
Yeah.
Yeah. Nope. So can you guys can do this one? Anyone can do this one?
Yeah.
No, right? Okay, so if nobody can do this one, we want to find a better way to do this one. Okay, we need to find a better way. This not be factored. You cannot be factored right now. Factor is super challenging right now. So I use another method. All right, so I move the 7 to the right. I move 7 to the right. What I need to do here, I do take advantage of this one, all right? I use both sides. I take advantage of this one, okay? Plus 9, and right side is also plus 9. Is it okay? Can I do this one? Does it make sense, this one? Can do it like this one? It's great, right? So you can change this one, it became x plus 3, right? What about right part? Can 2. Do you see what's going on? So x plus 3 actually can be changed into positive negative square root 2. right? Anyone can understand this. So x can be both sided -3. You got it? All right. That's the reason why it's not easy to be factored. Understand? That's the reason why it's not to be factored, because of this is the not rational number, irrational number. So it's, if you want to factor like this kinds of integrative number, whole number, that will be easier, relatively easier. But it's not whole number. You cannot easy to be defined. But why I use the 9? But why are you introducing is 9? It's not something other number. Why not change 8? I know what change something else. Because I want to make this part become a perfect square, right? So we need to make it a complete square. Make it a perfect square, like this one, change it to this one, and would be easy, go next step. If I change only 8, I have to go factor again. That's not what I want. I want to be a perfect square. That's what I want. All right, let's see something different. Let's see a little bit different, change. So right now, what do we say? We +7, all right? Right now it's +7. When I trying to say, give any number. We can say any number, all right? I give any number, say it's 8. So I need just 8 + 9 here, right? Why I need 9? Why I need a 9 here? Because I can make it is perfect square, right? So you can easily do, right? So you can easily do this one, square root. So any number square can be used this one. So any number, you don't necessarily to define what it is. You can easily to get this answer by this way, right? So what doesn't matter what it is, what number it is, not 7, even anywhere number is will be easy to get. Okay, so okay, let's see another example here. So just like earlier saying, if you know a perfect square equal a whole number, so it can be, you can just use the square root. You can just use the square root to get at least, they have positive or negative 15, right? Have two difference. So like this one, so like this one. So I can got these kinds of answer quickly, all right? All right, let me see, give you another example. Okay, so can you guys use this one for factor methods? Use the factor methods. Yeah, we can use the factor methods, right? It's positive 4, -2, right? So you can get the answer is -4 and +2, right? So we use the factor. Most of the time, you can still use the factor methods to get the solution and use the zero factor kinds of thing. Each of the one of the factor need to be 0 and you get a solution. At the same time, we can still use the square root methods, called radical methods, or you can do square root methods. Anyone else confused? Ryan, you confused? Yeah. All right, anyone still confusing? Okay. Ryan, I know you say you're confusing. Okay, all right. So factor method, you are not confusing, right? Okay, so let's see this one, we use the radical methods, all right? All right, so let's do proper transform first. So x squared plus 2x equal 8, right? All right, so how we can make this perfect square? How we can become perfect square? Anyone can, any idea? I need a little bit down here. Say we know this one, right? X plus 1 square equal what? X squared and 2 times of the 2 terms, 2 times of the 2 terms plus is 2x and plus 1, right? Did you guys still remember can do this one? Can you guys do this backward and frontward? Both of them. You can do this one, you can do this one. This is a need very familiar in your mind. X squared, A plus B, right? A plus B squared. We talked about this a lot, equal A squared plus 2AB plus B squared, right? Right. So let's look one. So we just need 1. Actually, we just need 1, right? We use the advantage of this. We just need 1. So we can plus 1. Where's the 1 come from? Why I need 1? We use this one. 1 actually come here. Why we need 1? Because we want to make this one become perfect square, right? So you can got after, so radical both sides. So this now I can break it down positive 3 or negative 3, right? So x can be equal negative 1 plus 3 or minus 3, right? When the plus 3 equal positive 2, when the minus 3 became negative 4, answer is match up, right? So we just, the key point is how to find this one. How to find, why we find 1, all right? So actually 1 is come from where? So suppose let's look this one first, look this one. So A, if I change X, A change X, so here it became 2BX, right? 2BX, right? So if someone just told you only these 2 terms, how you find these terms? List only these 2 terms. How you find this? How you find this one? Right? So you needed to break this down half. The coefficient of the second term of this one, degree of 1, broken down half, and then make it square. All right. All right. Break down this 2b into half. Well, only this 2b, they just, not most of the time, they don't write like 2b, they write a number. Like this one, they write actually, write is 2. So what's the b? 2 times what equal 2 times 1 times x. So the b actually equal 1, right? The b is 1. B squared is became 1 here. This one is actually from the 1 square come from, right? Okay, let me give some more examples. Make sure you can get well understanding. I know this one a little bit not easy to understanding. Let's see one example. Say x squared plus x. How to be changed into, make it change into x plus something square? We need to know this one. What's this one? How we make this one, right? So actually we needed to, this number actually is b. B is right here. Half of length. And then make it a square. All right. So this one, you can do this one. You can, if you don't know, do backward. Do this word. Is it the same? X plus. If you do this way, right? So you can got first term square, second term square, and don't lost the middle one, all right? 2 times first term is x, second term is b over 2, right? See, so delay match up. So you need to backward. So right now we do want to find this way, from the right, left to the right direction. Only tell you these 2 terms, how you find this one. So we can generate these kinds of perfect square. All right, and now I need a real example now. Real example. Let me pick one from our homework. Okay, say x. Example. Let's new example. All right, ax how to make this perfect square? How to find a third term? So you can change it into something square. We need x plus what? Plus what? What's the number? What would it be? What do we need to find? What list would it be? Anyone can answer what list would it be?
16.
16. 16 here actually is come from 4, right? Why we need
Yeah.
4? Why we need 4?
Because
It's come half
it's
one. Half of this
yeah.
one is 8 over 2, right? Actually, it's 8 over 2, right? So you can. So actually, if you rewrite here, definitely it's 4. It's 4. The 4 come from half of this one. Half of this one. So the coefficient of here is 1. So you half of this one, you can get 4. So you can get here is x squared plus ax. Actually, here is 16, right? So here, did you guys make sense? If you rewrite like into this, it will make sense, right? So if you do the polynomial special product in this progress, right to left, you can get this one. So if you go left to the right, so you need this 16 can change into this one. All right, let's see a little bit more here. Okay, let me give examples here. More examples. Okay, 2x squared equals nx plus 1. So how we do this one? How we do find the solution of this one? Okay, so we do the proper transform first, all right? Proper transform. Okay. X squared minus 10x equal 1. This correct. Is there anyone can do this one first step? So firstly, we make sure what important. Make sure this one the coefficient should be 1. So we need both sides, left and right side, divide 2. All right. Divide 2, both sides. Okay. So right now is these two terms, we need to make it perfect square. We need to find the numbers. How number? Number is come from this one, right? So come from this one. Put this number is put right here. Divide 2, all right? So the special here, everything, I mean, this number, the 2 here, this 2 square, this is defined. Well, you don't necessarily care about this 2 number. Only thing you need to move this 5 right here. So the right side, since you add this one into the left, the right side, you do the same. All right. Okay, so you can see what is this change into. Actually, I'm sorry, here is not only 5, it's negative 5. Oh, I'm sorry, a little bit long. Here is negative 5. If negative 5 divide 2, here is negative 5. But after square, they are definitely the same. So you can cut it here. So here is the denominator is 4, right? So here denominator is currently 5 plus 25. So everyone got it? This is where the most important, how you find these terms. So if you do backward, you definitely can understand better. So it's x squared, right? And this negative 2 5 squared became right here. And 2 times of this 2 became the middle of the term. All right, so here actually is 227, I'm sorry, here is 427 over 4. So both side radical square root, both side. So you can cut it here, okay? All right, so this one you can further simplified. Here became 3 over 2 square root 3, right? So x equal, so move this one to the right. So you got here. Right? It's more easier, right? I don't know. Someone mentioned like during in the chat anything. Auto, Bradley. Anyone else confused? Ryan, do you still confusing here? Ryan?
No.
No, it's better now. You understand a little bit better?
Yeah.
Okay. All right. That's good. Okay. Let's see some. If you still confusing, let's see some more. All right. Let's see some more examples. Will be get better. Okay. Let's see this one. You guys can factor this one? Anything can be factored this one? 14 can be factored into 2, 7, right? 1, 14, right? That's all. But the sum of them is 9, the sum is 15, so you cannot be better factor. So factor methods is not feasible here. So we'll see something different. Use our radical methods. So here became negative 14, right? So here is 10. All right, so the methods I just added here one more time here. Remind. So we actually is negative 10. Negative 10. Now, what do we how to find this one? We only need to find this number is this negative 10, put the right here, right? Divide 2 and make it a square, right? So firstly, need here the coefficient here is 1, and right now here the coefficient of least degree of 1's terms, the coefficient is negative 10. You make a negative 10 right in this position, and half of them of this, and make it a square, right? So you do the same one in the right part. Make sure you do the same one in the right part. All right. So actually this is negative 5. So it's negative 5. If you do backward, it's definitely well understanding because you guys do very good at the polynomial special product, right? So here is negative 14 plus 25, right? So you can actually here equal 11. So it means the both sides square root. So x equal what? 5 plus minus 11 square root. Right? So this is the answers. This is the answers. Okay. All right, let's see a little bit more. Maybe more example would be making you guys more clear. Have you guys write down this one in your note? You guys make notes most of the time?
Yes.
Yes.
Yeah.
Excellent. Please make a note, all right? You need to make notes, all right? All right, let's see some more examples. I make sure you guys still can clear. All right. Hello, Brian. Didn't finish yet. All right. 10 more minutes. 10 more minutes. All right. Yep. Okay, so see this example. You guys can factor it, maybe, right? You can maybe factor this one, but today for now, if you cannot factor, use these methods. We call radical methods. We also can square root or complete square methods. All right. So how we to do that one? Firstly, let's do this one. Please firstly make this kinds of coefficient become 1. All right. So it means both sides. I mean all the side, both sides, left side, right side, divide 4. This one became 1. That's the most important, became 1. So here became 2x, negative 2x. Right? Move the negative 5 to the right. You guys can go this step, definitely no problem, right? All right, so we need to make this one become perfect square. How we do that? Just like what we earlier saying. So we need this one is -2. Put a -2 right here. Half of them, and then make it square. All right. That's what we want. That's what we want. Actually, this is 1. That's 1 come from. Same thing here. Since we do the thing, we also do the same number, exactly the same number in the right side. So it means both left side and right side add the same thing. They don't change the equation, right? Let's rewrite this one. So this one definitely in your mind. What this could be like? Rewrite like this. So right part here is 1, is 9, right? So left half became x minus 1 square. So this one, square root of this one have 2 of them, right? X, right? So x equal what? I'm sorry. This, I'm sorry. So if we here has square here is write like this. X minus 1 equal positive or negative, right? So x can be 1 plus or minus 2. So first one would be, and second one would be -1/2. You have 2 answers. Got it? Everyone got it? But definitely you guys can do the factor. I think it looks like this one can do factor process, right? 4 times 20 is -20, -20. 4 times -5 and -20. You can be factor this one by factor methods actually, if you do greater progress. All right. Let's see another example. Yeah, example. +7 equals 0. All right. So can you guys can still maybe can do factor, maybe cannot, but I'm not sure this one. So right now, today I do not focus on factor methods. I focus on the try to complete the square, perfect square. All right, so first the same, make this coefficient, the coefficient in front of this one became 0, it became 1, sorry, not 0, 1. So both sides divide 2. This 7 divided 2 became negative, right? You can get it here. All right, so we try to make it complete square. What do we need to do? So we know the b right here is +3. So we can be changing into +3 over 2. Half of them, all right, half of them, then make it square. The same to the right part. Half of them +7 here, right? So you can get it here, x plus 3 over 2 became what? Here is 4, right? -14 plus 9, right? You got it? Ben, you joined late. Ben, did you see earlier part? Okay, so here get -5 over 4, all right? So you can see this one actually is somewhat confusing. A sum number, let me rewrite it here. A sum number, I mean, what number? Square became -5 over 4. So it looks like it's not make sense, right? It's any number, most of the time, after the square, they are at least is 0 or positive number. But here give you a negative number. So it means there's no solution here. There's no solution that you guys can make it became, -5 over 4. Right now it's no solution, but when you go to the high school, they have solutions, all right? I give you a hint here, a little bit more here. Actually, this one in near future, if you want to do, you go to the high school, you will be changed into like this. And a number, if it became -1, after square root became positive negative I, they call imagination number. This is not real number, all right? So the same imaginary number became -1. The same thing. This is will be answered when you go to the college, go to the high school, but not in this. One of my homework actually signed this one. I accidentally signed this one here. So this one can be changed into, you can choose no solution, or you can change into is x plus 3/2. Here became, actually this one became time -1 here. Positive, negative, I. All right, so x equals 3/2. I. All right. So you can answer this kinds of thing if you're in the homework. Have this part, sorry. All right, let's give one more example before we end today. All right, so if we, most of the time, if they are negatives, then we consider no solution. But if you still have the, can further develop, they still have some answers. Excuse me. All right, let's give one more examples. We say 2x squared. I think I talked this one already. Sorry. Okay, so still this one. All right, so see this one. How will I get the solution? 31, this is a prime number, right? You know, this prime number not easy to be factored, right? 1 times 31 definitely is not equal -12, so it's not easy to be factored. So we have to use the perfect square methods, right? Okay, so move the 31 to the right, it became here. All right, so how we find these terms? How we find these terms? How we find these terms? Right? So we know this one is -12. All right, that's important. -12, half of them, and then make it square. The same thing. Half of them and make it square. All right. So actually, let's rewrite it here. Rewrite it here. Here actually 36, right? Right, it's actually 36. So that's 36 come from. So actually this one is come from 1. Right? So here became 5. So you can get positive negative square root of 5. So k equal to what? 6 plus minus square root of 5. It's easy. You guys, yeah. Okay, so most importantly, progress is how to find this one. All right. Let me write a general method. So I say, if you say ax plus b plus bx, find this term. All right. So firstly step is we take the a out. All right. Take the a out. So b over a. We don't know what's this, the third number here, all right? I don't know what's this one. So I don't know what's this one. I don't know what it's neither. All right, so how to make it perfect? We need to half of them. So after this is 1, and we find the coefficient is this one. Half of them is what? 2a, right? and make it perfect square. Right? So let's see. Can we rewrite like this? B over 2a square. If you don't know how to this come from, do backward, all right? Backward and do backward. Actually, with do backward, you can get this very well. If you do backward, this is the first term square, second term square is right here, first term square here. 2 times of this one and this one will equal the middle of these terms. So when you distribute a inside, you will get it here, right? So actually, this one became b squared over 4a squared, right? And this one will be b squared over 4a. Right? So it's a little bit complicated, but I don't necessarily you guys remember this all the time, but just make sure that how to, when you know these kinds of coefficient, how you find the certain. That's what we have. All right, so today's homework code. Let me see homework code. Homework code today is. Can you guys write down? Oh no, my computer is super slow. That's not good. I got it. Yeah. 465215. Today's homework code is 465. I put it in the chat area, right? I don't know. Did you guys go to the chat? Go to the chat. 465215. 465. Let me rewrite it one more time here. 465215. This is today's homework code. All right, so see you next week. A good day, everyone.
Okay, bye.
Bye.
Bye-bye. A good day. See you next week.